Hi, welcome to another video of machine learning. So far we have discussed mainly how we can start our machine learning project and how we can build our model, how we can train our model, and how can we set up the hyperparameters, how we can tune the hyperparameters so that we can get the best out of the data whatever we have, so we can possibly build our the best model out of the data we have, right? And now we are going to discuss in this video how we can in the final step how we can deploy the model. Okay, so that is model deployment, the deployment of the machine learning model. So here we will basically, suppose you got the approval to launch, and basically you are satisfied with your model that you have achieved a significant amount of performance. You have achieved a significant amount of performance from the data, and your machine learning model is doing a great job, and you got the approval to launch. So so you now need to get your solution ready for the production, right? And basically in this stage what we'll do is that we basically mm, launch, monitor, and maintain your system. So your main thing is that you're going to polish the code a little bit. You're going to polish the code a little bit, your final code. You write documentation for your project, and finally you run a test run over the, and you see that whether it is working properly or not. And 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 So one way to do this, that how we can deploy the model, is one way to do this is to save the trained scikit-learn model uh, using including the full pre-processing and prediction pipeline, is to then load this trained model within your production environment and use it to make prediction by calling its predict method. Okay, so what we are going to do is that you are going to save the your scikit-learn model. Suppose you have built a scikit-learn model using, suppose, job lib. There is a for this you usually use the job lib, sorry, the job lib job lib library to save the model, including the full processing and prediction pipeline. Okay, so we are basically, what you are going to do when you inference is doing, you are basically, you use the full pre-processing step, the feature extraction, data processing, everything, and we need the inference model. You going to use the predict function. We are going to use the inference, so we are going to use the predict function of your machine learning model. Okay, so here, so this way you can basically so you need to save this scikit-learn model using joblib library, and you are going to make the prediction by calling the predict method. Okay, so for example, perhaps your model is used within a website, right? So user will do, user will send some data, some query data, that which are required for the predictions. And suppose these are features, this may be some data which is required for prediction, and this will send a query to the containing the data to the web server. Okay, or web server, which will forward it to your web applications, and finally your code will simply call the model's predict method. Okay, so alternatively, obviously, you can wrap the model within a dedicated web service that your web application can query through a REST API. So REST API means that is a HTTP based API that follows some application conventions, such as using standard HTTP verbs to read, update, and or delete the resources. Okay, so this way, this makes it easier to and this way this it makes it easier to upgrade your model to new versions and without interrupting the main application. And also it simplifies the scaling since you can start as many web services as needed and load balancing and the requests coming from your web application across these web services. And moreover, it allows your web application to use any language, not just Python. Okay, so this is a typical way of deploying a model as a web service and used by a web application. Okay, this is just an example, so I'm not going into the details in this video. I will in the subsequent lectures I will discuss in particular way how you can do this task, what is the way of coding, and everything I'm going to discuss. But this is just an introduction, so how the model can be deployed. So another popular strategy is to deploy your model on the cloud, for example on Google Cloud AI. So Google Cloud AI, you can deploy your model. Okay, so so this is also formerly known as the Google Cloud ML engine, machine learning engine. And just save your model using the job lib and upload it to the Google Cloud storage, and then head over to Google Cloud AI platform and create a new model version and pointing it to the GCS, that is Google Cloud storage file, and that's it. And this gives you a simple web service that takes care of load balancing and scaling for you. And what it does is that it basically sends a JSON request. So JSON means probably know that if you working in working with databases, you probably know that JSON stands for JavaScript object notation, and it is usually text-based format that represents structured data on JavaScript object sentence. And it is used in cases like when a server needs to send some data to the client and it can be displayed on the web page and vice versa. Okay, so this way it take JSON request containing the input data and returns the JSON response in containing the predictions. So everything is done through JSON files. Okay, or JSON request or response. So I have basically talked about the job lib function for models deployment, but a similar way for scikit-learn model. But similar way, the tensor deployment of the TensorFlow model is not much different from deploying a scikit-learn model. Okay, so you probably know that the TensorFlow model is used basically for your neural network architecture, and so that is also quite similar, that you can do everything, almost all the same task with your TensorFlow model, whatever you can do with scikit-learn model. Okay, so the important thing is that this model deployment is not the end of the story. So you also need to write monitoring code to check your system live performance at regular intervals and trigger alert to the to whenever its performance drops significantly. So this could be a steep drop likely due to some broken component in your infrastructure, but be aware that it could also be a gentle decay that could easily go unnoticed for a long time. And this is quite common because models tends to rot over time, because its performance gets degraded with time, and this because the models was trained on the last year data, some previous year's data, and it may not be adapted to today's data. So it is very important to monitor your model live performance. But so how you can do that? So you need to put in a place where you use a monitoring system. Okay, so and all the relevant process to define what to do in case of failures and how to prepare for them. So all the relevant monitoring system and all the relevant process, you have to define how you're going to what are you going to do if in case of any failure or any model performance degradation you observe, then how you should what steps you should take. Okay, so if the data keeps evolving, you will need to update your data set. Okay, so that is one important thing. So suppose you trained your model on some data set, and it is performing well for this timing, but when you are getting some monitoring issues, that performance issue, that it performance gets degraded because your data set is not updated. Okay, so your model is not updated, so you need to update your data set and retrain your model regularly. So you should probably automate the whole process as much as possible. And obviously you can automate few things over here, and those are things. Suppose you collect the fresh data regularly and label it. So, and labeling is a tedious job, and for this you need to some human records, sometimes some human intervention is required, but you need to do that thing, so you need to take care of those things. So write a script, and also you need to write a script to train the model and fine tune the hyperparameters automatically, and this script should run automatically for a regular interval, suppose for every day or for every week depending on your needs. And write another script that will evaluate both the model and the previous model on the updated test set, and deploy the model to production if the performance has not decreased. Okay, so these few things you can do parallelly along with your deployment, so that you can properly maintain your system performance, and that will give you a sustainable performance over a big period of time. Okay, large period of time. So as you can see, this machine learning, the whole thing from the starting from the raw data and building a machine learning model and then deployment, and all this machine learning end-to-end process involves a quite lot of infrastructure. So don't be surprised if your ML project or machine learning project takes a lot of effort and time to build and deploy to production. Okay, so hopefully this all discussions, the last few videos, gives you a very good idea of what a machine learning project looks like, and as well as showing you some of the tools that how you can use or train a large system and a system. And this particularly we have discussed the data preparation step, building monitoring tools, setting up human evaluation pipelines, and automating regular model training. And obviously the most important part in machine learning is also the machine learning algorithms, and of course it is probably preferable to compatible with the overall process, and you should know at least 3 to 4 algorithms properly to explore, rather than exploring all the advanced algorithm. You should know at least 3 to 4 machine learning algorithms properly, so that you can work with any data set. Okay, so thank you for watching, and it's a good time for you to start any project, and such as you can start from the Kaggle website also. So this is a very good place for doing project for the machine learning. So thank you for watching, and keep on learning. Happy learning. Goodbye.